Hi guys, for this advanced concept presentation, I'm going to walk you through the steps involved in generating ATP. You've got glycolysis, and from glycolysis, in the process of glycolysis, you have glucose turns into glucose 6-phosphate, which equals they consume 1 ATP. Fructose 6-phosphate to fructose 1,6-biphosphate consumes 1 ATP. Glyceraldehyde 3-phosphate changes to 1,3-biphosphoglycerate, and that produces 2 ATPs, one from each mole of glyceraldehyde 3-phosphate. 1,3-biphosphoglycerate turns into 3-phosphoglycerate, which produces 2 ATP. Phosphoenolpyruvate changes to pyruvate, which produces 2 molecules of ATP. Pyruvate to acetyl-CoA equals 2 NADHs. Now, the conversion rates for all of these productions into ATP, your NADH equals 2.5 or 3 ATP. Each molecule of FADH2 is 1.5 or 2 ATP. And then 4 protons equal 1 ATP. FADH2 is 1.5 or 2. I don't think I said that correctly. So then you go to the Krebs cycle, and you start with isocitrate, and it turns to alpha glutarate, which is 2 NADH. Which consumes 2 NADH, produces 2 NADH, sorry. Alpha glutarate to succinyl-CoA produces 2 NADH. Succinyl-CoA to succinate produces 2 GTP, 2 ATP, 2. Succinate to fumarate produces 2 FADH2. Malate to oxoacetate produces 2 NADH. So you have 5 molecules of ATP produced in the NADH. You get 5 molecules of ATP out of 2 molecules of NADH. And then you get 2 NADH from succinyl-CoA. And you get 2 GTP, which equals 2 ATP. Then you get, from fumarate, you get 2 molecules of FADH2, and then you get another 2 molecules of NADH from malate to oxaloacetate. Sorry. So your total is you've got 5 ATP plus another 5 ATP plus 2 plus 3 plus 5, which gives you a net yield of 30 or 32, depending on whether you use the 2.5s or the 1.5s with the 2s and 3s. So this is how many are produced, and thank you guys for listening.